starting. Okay, there we go. It's on air now.
Perfect.
All right, so let's get our quiz up, and it's lesson 18 group meeting quiz. All right, I'm doing 1 and 2 right now. Okay, so 3. While you're required to work together on this quiz, each member of the group must submit blah, blah, blah. There's a normal probability applet we might need. Okay, so for the next 9 questions, so it's 3 through 12, we'll review the PTC tasting study with different data. Okay, let P1 be the proportion of females in the population who can taste PTC. At P2 be the proportion of males who can taste. So P1, P2. P1 is let's see. Okay, so P1 is females, P2 is male. Okay, is the proportion of females who can taste PTC different from the proportion of males?
Beth, I think Beth invited us.
Oh, did she?
Yeah.
Okay. Gosh, I didn't get. Oh, like by email?
Yeah.
Okay. Let's see. Where's my?
Maybe she's gonna join 2 hours. I don't know. I'm not sure, but.
All right, I have to get. Excuse me. I gotta get onto my Gmail. Let's see. Where is the? Okay. So that's interesting. All right. So I will do my Gmail. I hope it is. Oh, good. Okay. Oh, see, I'm not even seeing it from her. I don't see anything from her.
Oh, really?
Yeah, interesting. Okay.
I'll just email her this link and
see what happens. Okay.
Yeah.
Okay. Yeah, I didn't get any answer from her on the cell. How bizarre is that? Okay. Okay. Control C.
Okay, hope that does work. Okay, so are we on question 3?
Yes.
Okay.
Okay, so I sent her an email to. Oh wait, I'm just got something. Nope, not her. Okay. Darn it. All right, so what is it? It is. Okay, it says
the X1 is 52, the female, yes, and N1 is the 70, the total, female total. That's what I put.
Okay.
So I'm using categorical whatever.
Okay, are you using the Excel spreadsheet?
Yeah.
Okay, and so for X1, that would be those who can taste.
So yes,
That
so
would be
female.
52. And then N1 would be the male, yes, 42.
Yeah, X2, yeah.
Okay, and then X2, well, wait a minute, so am I off?
So N1 is the 70, so the female total.
Oh, okay, thank you. Okay, female total. And then X2 would be males, yes, 42, and 59 is?
The N2.
Okay, and so basically, P hat is it saying P hat 1? 0.743, 0.743?
Yes, 743 and
Hi,
712.
Hi.
Sorry I'm late.
That's okay. I thought it was my link. My links are always.
Well, I think I didn't refresh my email because I had my email open and I couldn't see anything. But then I closed it and reopened it, and there were all your messages. Sorry. I remember whose time it was to host. So thanks for redoing the schedule.
Yeah, I totally forgot, sent it out, and Maki said it was my turn, and then Maki can't do it on Thursday. So Ani and Maki were talking, they can swap, and then we don't have it for Thanksgiving, so.
Yeah.
Okay.
So basically, we just finished answer 3 on the quiz.
Okay.
And we have, what we're using is our categorical data analysis HAT Excel spreadsheet.
Okay, I have that open.
You have it open, okay. And so with number 3, we plugged in the data. So the females, P1 is the female population who can, the yeses, and N1 is the total female population. And then X2 is the male yeses, and N2 is a full male population.
Okay. So okay. So 70, 52.
So the first, so your X1 would be 52.
Isn't N1 52? Oh, N1 is 70?
Yes.
Okay. Oh, the yeses are 52. Okay. And the 42 out of the 59. And we're doing a 95% confidence level.
Let's see. You know what? I didn't see.
It doesn't say.
Yeah, it doesn't say. So I think just it defaults to the 95.
Okay, so so P1 is 0.743.
Yes. And then question 4 is what is P2? And that's nice. It has that one for us too.
Yeah. Why can't they all be this easy? I did so bad on my homework quiz. What was it, 17? It was bad.
Yeah, mine too.
I don't know.
That was bad.
But I got 100% on my 16. I was shocked.
Ooh.
Oh, wow.
I was pretty impressed with myself.
I would be too.
So the hypothesis question. After I was reading this chapter, I think I did my thing wrong, my design the study wrong, but we can talk about that after.
Okay. So I think question 5 is the first one because that information doesn't say anything about less than or greater than, and it just says different. So
I think
yeah, different.
how I read it, it's usually equals or doesn't equal.
Yeah, so it's just
Yes.
not equal to P.
Yes, it's that first one.
So
well,
the
wait a minute.
confidence interval is already listed there too.
So okay. I'm just thinking, okay, where's I took my note here. So
Yeah, is it the last one?
Oh gosh.
So
yeah, it's the P because it's dealing with P population, not P hat.
Yeah.
Okay, so it's the P. Okay.
Well, okay, I'm looking at something else.
Okay, let's see. Point estimate for this 95% confidence level. So we've got, it's a not equal to. Okay, there we go.
Oh, we need to change the type of test. We need to change the type of test to P1 does not equal P2.
Yeah, it's to say the P hats are the same. Because what isn't it? X divided by P hat is X1 plus X2 divided by N1 plus N2. So you're not, the confidence level and the type of test doesn't play in at that point in that calculation. But for number 6, yeah. P1 minus P2 put in terms of point as a margin or a lower bound and upper bound.
I don't get that. P1, P2, P1 not equal P2. P1, P2.
Okay, so the point estimate, I thought that was the mean, no?
Yeah, I don't know. I just thought we're just gonna combine the female male who said a yes, and you divide by the female and male total people. But then it is not the answer.
Okay, what is the point estimate with a 95% confidence level? The point point estimate 2% confidence interval. We have the upper and the lower.
It's not 0.154?
Oh yeah, that's question 7.
Oh, no.
Yeah, that's the margin of error.
That's the margin of error. What's point estimate? What are they looking for?
Well, Sinai said the point estimate was the mean. I don't know. So instead of
it's not the p-value?
It's P. It's okay. So isn't the point estimate really in unit 2 was like the mu, and now isn't it the P?
I think I know what you're saying, but is P hat 1 different than P?
Yeah, probably P is the point estimator. Oh wait.
Okay, confidence. So we are okay, and we're dealing with confidence intervals. So
I don't know. I thought P hat is the point estimator.
I think you're right. I think it's P hat.
But
which one?
So
which P hat?
So we usually combine the numbers. So like the female and males, yes.
Add it.
The total is what was that?
94. Yeah.
And the female and males total, like in general, like both, like who said yes or 129. But then I divided by, so I divided 94 by 129 or whatever. And it didn't work. that was a wrong answer.
So
But then
0.729 is wrong.
yeah, that's what I put, and then yeah, it is wrong. So I just like, that's so weird.
Okay,
It's
129.
point estimate.
Yeah, because the textbook at the end of the textbook, like lesson 18, talks about the point estimator, and then like that's the right way to do it. Overall sample proportion p hat, but then it didn't work, so I was just like,
Okay, so did you round it 0.729? You did, okay. The estimated proportion of patients, okay. Okay. Let's remember lots of details. Bam, bam, bam. I'm going down to the end here.
Shall we just skip question 6 and then
go from there?
Yeah, because we can find other answers without getting point estimator. So
yeah, overall sample proportion, p hat is x1 plus x2 divided by n1 plus n2. We're just gonna, whenever 0 is contained in the confidence interval of the difference of the two proportions, we conclude there is no significant difference between the two proportions. I don't know if that makes a difference. And 0 is part of the confidence interval. Whenever 0 is contained in the confidence of the significance of the true proportion, we conclude there is no significance between the two proportions. So there's no significant difference. Interesting. I wonder if we
We didn't even talk about point estimators in this chapter.
Yeah. The last lesson 17 talks about point estimator, but
okay, so I'm gonna try here. I'm gonna see if I get a different if I do the so 0.7428 less
p hat is called a point estimate of p.
0.711.
Or the information says P1 minus P2. So if we're gonna probably because so the female yes is 52 and the male yes is 42, so you subtract 42 from 52 and you get 10, and then from female total 70
so
minus
20,
male
29.
Yeah, total 59, you get 11. So that might be the point estimator. 10 divided by 11.
Oh, okay.
So you get 0.909.
Oh,
I don't know.
Well, if you add p hat 1 and p hat 2 and divide it by 2, you get 0.727, which is
really?
1/1000th different.
Wait, how did you get the answer? Sorry.
Well, if you add if you add p hat 1 and p hat 2 and divide it by 2, it's 0.727, but that could be totally like not even close. So
yeah, because the information says P1 minus P2, and the textbook actually. So
does it combine the two?
Yeah, it says equal. P1 equal P2. So maybe it doesn't work in this question. The x1 plus x2 divided by n1 plus n2.
Yeah.
That doesn't work in this situation, I guess.
Well, do you want to try the 0.9? You want me to try the 0.9 that you came up with?
You compute p for each group.
Well, maybe you can try to divide it by 2, 0.7 something something, I guess. I'll go for 0.909.
Yeah, 0.909. Let's see.
I'm not sure. But
Uh,
P hat is 1 point on the number line that estimates the value of the true proportion. A point estimate like P hat is helpful, but it does not give us direct information on how close it is to the true parameter P. We use a confidence interval to find a range.
Okay, what's our margin of error? The margin of error is
0.154.
0.154. Okay, is that on the spreadsheet or no? You figured that one out.
You subtract the confidence interval. Bless you. You subtract negative 123, the lower bound, from the upper bound, and then you divide that by 2.
Oh, okay.
yeah, I'm too lazy to like calculate. I always do it. I'm just like,
Okay, so it's all right. So I could do all right. Boom minus boom, and then divide by 2. Okay, I see. Okay, thank you. All right, there we go. Yeah, I got it. Okay.
But P hat is a point estimate. I'm surprised you didn't get the first one right, because that sounds right.
yeah, it's so
Well,
weird.
it's following it exactly as they're stating it.
Yeah.
It's weird.
Okay, I lost my test. Where am I?
Okay, negative 0.123 for lower bound. And upper bound is 0.185. Okay, so our p-value is 0.693. So we are going to fail to reject the null hypothesis.
Yeah. Well,
and if we fail, we say there.
Oh yeah. So did you choose fail to reject HO?
Yeah, fail to reject HO.
Okay.
And then on 11, it would be there is insufficient evidence to suggest that the true proportion is different from the true proportion male. So the last one.
Yeah.
Did you do your applet?
No, I just looked at the spreadsheet.
Oh, you just used the 0.693?
Yeah.
Okay. So, I'm lost.
So it's not equal to would be both sides, and it's 0.69.
So we are failing to reject the
That's
HA,
interesting.
right?
H0.
And wait, fail to reject H0. Okay. And then there's insufficient evidence to suggest it's different from the true population. Oh my gosh, how many questions are there? 20.
Yeah.
21 today. 20.
Hey guys, which question are you
So
on
we have
now?
9 more to go.
Hi, Ani. We're on it.
Three.
12.
Okay.
Patients admitted on weekend who died. Okay, so, all right.
Died X.
P1. Okay, so it's the weekday who died is 16/7/13. 16/7/13. And out of 118,519. And then X2 or P2 is admitted on weekend who died. Weekend died 6155. And total is 42447. So did everyone get their numbers? X1 as 16/7/13.
Yeah.
Yes.
N1 118,519.
Yes.
X2 615. Oh, N1 would be 11. Wait, yeah,
Oh, I did that.
118,519. X2 would be 6155,
Mhm.
and N2 would be 42447.
Mhm.
And we're looking at a 95% confidence level.
Yeah.
Research questions.
And the
Is
type
the
of
portion
test
based order?
is P1 is less than P2.
Ah. Is the person with a heart attack admitted to the hospital on a weekday? Less than, okay, yeah. Okay. All right. Okay. Are the conditions of the hypothesis test satisfied?
Yes.
Yes. And the hypothesis is always equal to, and then we want less than on the alternate. So the last one. Is everyone on question 14?
Mhm.
I'm getting there. Hold on.
Okay.
Okay. Use the data to find P hat 1.
What does everybody have for 1 and 2? P hat 1 and 2.
It's 0.141.
And point
And
145.
Yeah.
Okay, that's what I got.
Z score. Minus 2.020.
Yeah.
C squared.
Okay. So we should shade the left. What is the p-value for this test? 0.022. I'm plugging it in just because. Yep.
When they,
You know, yes, that's correct. Okay.
So we are going to reject the null hypothesis?
Because
Yeah.
our alpha is 0.05, so it's
Yeah.
less. So reject null. So there's sufficient evidence. So it's 3 or 4 to conclude the proportion of patients who have a heart attack and are admitted to the hospital on a weekday who die is less than the person who have a heart attack and on the weekend.
Mhm.
So it's number 3.
Mhm.
All right, I'm being brave. I'm submitting.
What did you put for number 6?
6. I would go with
0.909, but I got it wrong.
Yeah. Oh, really?
Yeah, got it wrong.
I'll try the...
That's the only one I got wrong. That's just so weird.
Oh,
Mm.
I have to put my old data back in. I forgot and changed all my data. What was it before? It was like
Yeah, it was that. It was
727. It was 0727. 27 or 272?
Oh yeah, it's 0.7286, right? So 0.729, but yours was a little bit less, Beth.
Yeah, I think it was 727. We'll see. Did I save everything? Yes. I'll be surprised if it's right. Question. No, I didn't get it right.
Mm.
Man.
Holy schmoly. Oops. It's not that one.
So I wonder, is it just 0.141? Do you just use p hat 1? No. Point estimate. Point estimate.
I wonder if like they're wanting to use the, I don't know. Okay, wait, which one is, okay, what's the question? What is the point estimate for this 94%? I wonder if we could use like the standard deviation of the confidence interval, which is the same as the standard deviation of the hypothesis test. 0.002, because standard deviation, wouldn't that be considered a point estimate?
Well, it's
if they're not
0.002 anymore.
Huh.
You had different data in there. Do you remember what your data was?
Oh, no. I just said it was, oh, that's right. Sorry, yeah. I don't remember the data.
Okay. Well, do you guys have any questions? Did you read the chapter about the chi-square, whatever?
I haven't read it. Did you?
No, I didn't. I haven't.
Well, and so that's what I based my design the study off of. Did you guys watch the teacher's meeting he had? I did. So he sent a message saying, make sure you watch the last 15 minutes. And he said, this is why I don't want you guys doing the M&M study. So, but I think our question was different because what he said, make sure you have a good argument at the end of, or not a good argument, a good, what step, what are you going to do with this information?
Oh, that's your final, yeah. Is it, okay. That's your final, yeah.
So what are we going to do with that information, knowing that M&Ms are still being made at the same ratio in 2016 as they were in 2008?
I'm totally going to invest in their company because they're reliable. I mean,
I'm going to buy stock. We can buy stock because they have not changed their M&M ratio.
Yeah, and if we want to, if we're putting on a wedding reception or a party and we need a certain ratio of red M&Ms, we know, right?
You can order custom colors though, so that doesn't make a difference.
Isn't that cool? I know, yeah. You can even get those in the stores.
What about if we did, if we saw that the stock, so they say they have changed, so we would say, oh, well, they're a solid company because they can change their ratio and still sell lots of M&Ms.
Yeah.
Yeah. See that? Yeah, that'd be good.
So, Lori?
What?
You did watch his meeting?
No, I didn't.
Okay.
No,
I just
I know I should have.
15 minutes.
Yeah,
But
I need
I'm
to
gonna
go
watch
and
the
do
rest
that.
of it. It sounds like, well, and he says he's not gonna look at them till probably Thursday. So if we get a reject on Thursday, maybe you guys want to have some ideas of
Mhm.
what you want to do instead.
Yeah.
Okay. Okay.
People were talking about pulling sports team stats offline or FBI data from how many arrests they make, or like crime data. There's certain websites that have their data on there. So it could just be gathering information, but
Mm.
if you can think of data that we could gather that it would make a difference in, I don't know what, where we'd have a good reason to even look at
Well,
this data.
Well, what if one of us was moving to a new area?
And I want to make sure my M&M mix is the same in Rexburg as it is in Barstow, or else
No,
I am not
no, I
going
was-
to school in Rexburg.
I was totally thinking crime, crime data, things like that.
Yeah.
What's the crime data comparison between, Barstow and Stockton or whatever?
Hmm.
Oh, okay. Like with college data, they do list their safety data for every university.
Yeah, they do.
So are all
Yeah.
universities the same as far as crime?
Yeah. Say, are there safer places, safer universities?
That's a good idea. I
Yeah.
like that one.
Mhm.
So we'll see what he says about the M&Ms, and I'll try and prepare something alternative in case we need it. Because after looking at, just looking at these hypothesis questions, I'm not sure we asked the correct questions. So if you go to chapter, oh, I was getting confused. So chapter 19 is the one that talks about the chai tables.
Okay.
And so if you guys read that chapter and see if that makes sense to use that with M&Ms.
Okay.
Like the chapter we just did talked about comparing
To
PHAT 1, but we're not comparing to orange to yellow. We're comparing 2008 to 2016. So I think it works, but I guess I need to try the formula in the, so if we go to the chi-square tab in Excel and put in a bunch of numbers, I'm not exactly sure how it works. So
yeah, and it confused me when I looked at it. When we were talking about it the other day, Beth, I'm looking at that going, oh my gosh, how do you do this? It's a little
so
intimidating.
it has 6 columns because there's
6
red,
colors.
orange, yellow, green, blue, and brown. So if I just throw a bunch of odd data in there, so, and we're only comparing 2 years, so we have
So it'd be
6
row
columns.
Would it be row 1 and row 2? So 6 columns and 2 rows?
So, so overall, I put the 2008 for row 1 and 2016 for row 2, and I put oh, we still have to have kind of equal amounts of M&Ms. Wait. Okay, so we have 100 M&Ms on 2008. And what was the numbers I put in that design? It was, let me pull it up. Design study. So $23, $23, $15, $15, $12, $12. $23, $23, $15, $15, $12, $12. So you put them in order of high to low, so you can do that graph, right?
Okay.
And let's just say that red and yellow were swapped as far as numbers, but everything else is the same.
Mm.
23. Oh, let me put the right colors in there. So, I'm sorry. Let's say that cayenne swapped.
Okay, so on 2016 row, what do you have across?
Okay, so I have cayenne, orange, green, yellow, then red, then brown.
Okay, cayenne, orange, green, yellow. I'm just, so I can see what you're doing, red and brown. Okay. And then your numbers across for 2008.
For 2008, I have 23, 23,
Mhm.
15, 15, then 12 and 12.
Okay. And then for 2016, you have?
Then I have 15, 23, 23, 15, 12, and 12.
Okay.
So
All right.
it gives me data. I don't know what it means, but
I'm like, where do they get those formulas down there? Because it says expected count. So
I don't. Yeah, what does expected mean?
Yeah.
Within and percent within.
Huh. So that's like
and it says. So the total, I see 50% on the second within percent. Wait, row 1. Total 100, expected 100, within 100, within 50%.
Oh, okay. So it's giving, in that row, it's giving you what percentage that color is. And within the column, it's giving you what percentage. So between the 2 years, it's 23%. I think is what it's. So like the percent within the row all the way across row 1, that equals 100%. And then you do the same thing for, if you add the 2 columns, like the percent within column, those are going to equal 100%. The 60.5% plus 39.5 is 100.
Mm-hmm.
So it's actually just showing us what percentage of the total whole for 1 year, I mean, within a year, and then across years.
I'm going to watch the video because just reading the chapter and this is not enough for me to really get it. So.
Okay, yeah, I love the videos. They're helpful.
And then, but yeah, if you guys see anything that's like, oh, this experiment's not going to work, then let me know and I'll redraft something else.
Okay.
Ready?
Yeah. Thank you so much for making this one, Beth.
Yeah, thank you.
Are you guys able to go to those stores and buy M&Ms?
Oh, yeah.
Do you have money? I know you guys are starving. We're all starving college students, so I wanted to keep it. Okay. So thanks, guys. Appreciate it.
Thank you. Thanks for doing the thing.
Sure. When is our next assignment due?
That's
next week?
Next week. But that's the individual ones. We just count.
Oh, so we need to go to the store this week and start counting.
Yeah.
If we have to get approved first.
Because it says we can't collect data until he approves it.
Yeah.
Okay, so hopefully we'll have some time in there to actually do the counting.
Yeah.
That should be the easy part. Column for how many we couldn't count because we ate them.
Yeah, I'm right there.
Yeah, I'm down with it. I'm down for that.
Yeah, me too.
Okay.
Okay.
Thanks, ladies. Talk to you later.
All right. Thanks, everyone.
Yeah, thank you so
Bye.
much. Good night.
All right, good night. I'm going to stop the broadcast now.
Okay.
Bye.